Hi, my name is Anthony Hart. I'm in Professor Maduri's EE 478 VHDL design class, and my research topic is concurrent built-in self-testing. Testing circuits after the fabrication process is necessary but interrupts the production process. Not every circuit that is produced is tested, but every once in a while the production stops to ensure the circuit is working properly. Built-in self-tests make it possible to test an integrated circuit without the use of external testing equipment and halting operation. This method makes monitoring an integrated circuit more efficient than using external pins of the IC connected to the automated test equipment. The use of external equipment can be a hassle. By building in a self-test, this can reduce the dependence on external machinery and extra labor. It also makes it cheaper in the long run. A concurrent built-in self-test is an external and basically invisible circuit which monitors and tests a circuit concurrently while the circuit operates its normal functions. There are many different types of applications of the built-in self-test, such as a power-on self-test or POST, which tests the hardware of a motherboard of a computer while it's booting up. A critical built-in self-test or a prioritized test which stops the function of the circuit in order to determine whether there is a fault or not in the circuit. A watchdog monitor or timer monitors the time of the circuit that it takes to complete its functions, and if there is any sort of delay, the watchdog circuit sends a reset to the circuit, which prevents any sort of physical or software damage to the rest of the oncoming circuits. There are different schemes for the concurrent built-in self-testing. They are generally designed similarly. First, an input vector of bits are the input into the circuit that is being tested. This vector will also be sent to the testing circuit. It is first sent through a comparator, which determines if the vector is a recognized test pattern, which tells the active test set generator or comparator, or the AGC, whether the test has begun or not. The AGC compares the input vectors to the needed test patterns to successfully complete a test. Once a match has been made, this is called a hit, and the AGC will send an enable bit to the response verifier, or RV. This captures the output of the circuit under test and compares it to what the output of the circuit should be. Input vector monitoring is the building block for the concurrent built-in self-test. It consists of different memory types: an incrementer, a decoder, XOR gates, and a comparator. The input vectors of the circuit under test are the inputs of the concurrent built-in self-test unit, or CBU. The inputs are sent to the inputs of the RAM and ROM memory. Once the RAM overflows with bits, the outputs are sent to a decoder and an incrementer. Then the outputs of the decoder are sent to the XOR gates and comparator. The input vector is also one of the inputs of the comparator, and if there is a match hit, an enable bit is sent to the RV. I have an example in my report which describes a circuit with 5 input bits and 3 necessary test patterns to complete a successful test. RAM-based input concurrent built-in self-testing is said to be a scheme with the lowest latency and used on testing the hardware of computer systems. This scheme is an alternative to ROM built-in self-testing. The difference between RAM and ROM is that RAM is capable of reading and writing, and also rewriting its data, as ROM is only a read-only memory. Except the benefit of ROM is when power is removed from the circuit, the ROM retains its memory. As for the RAM, it resets its contents to zeros. The RAM model of concurrent built-in self-tests revolves around the flooding of the RAM with input vectors. When the RAM runs out of memory, it outputs the highest bit and it sends it to the AGC. The AGC will collect the correct vector length and begin comparing the vector to a correct test pattern. Once the vector matches the correct pattern, the AGC will send the enable bit to the response verifier. Then the circuit under test output will be checked for any faults. But as soon as the power is removed from the circuit, the RAM memory is cleared and will be set to all zeros. ROM testing is one of the oldest ways of concurrent built-in self-testing. The AGC uses a gray code generator. The gray code, named after Frank Gray, which is a numerical code used in computing in which consecutive integers are represented by binary numbers differing in only one digit. This gray code is flooded into the ROM. With the addresses not relevant, we are unable to separate the test bits into normal functioning bits. Now, to analyze whether or not the ROM is faulty or not is done by monitoring the output matrix of the ROM. To evaluate the data matrix into a test pattern, the output of the ROM is XORed with the input strings of the circuit under test. Now the result of that should be all zeros for a successful test. But if there is a 1 in the stream of bits, this means there is a fault. Hence, the name of this design is called the ones detector. ROM built-in self-test ROM built-in self-tests are older, but are still applied to all sorts of digital circuits to this day. ROM testing used to be used for home computers for running BIOS, which is basic input-output systems. These became outdated due to not being able to update. Now BIOS is ran through flash memory chips, which are faster, rewritable, but less secure. Thank you all for watching my presentation. I hope you all go check out Austin Marinjoni's excellent term video. Thank you.